So far, all of the linear equations that we've solved have had a single real number as their solution. A quick example would be something like if we were solving 2x equals 6. Then we found that x equals 3 was that final resultant equation. And that statement x equals 3 tells us that the value of that value of x that makes that original equation true is 3, and so 3 is our solution. When solving linear equations, there are two other possibilities that can happen. The first is that the resultant equation is an identity, and that's going to be associated with all real numbers being solutions to an equation. The second is that an inconsistent equation can happen, and that's going to be associated with no real numbers being solutions to that equation. So to start, let's define an identity. An identity is an equation that is always true. So identities are equations that are always true. And by always, we mean for all values of the variable. So this means that all real numbers are solutions. A quick example would be something like, I'll show a couple here. So an example that we could solve to would be something like 3 equals 3. That statement is true in every case. You'll notice that there is not an x present in that equation. So when we're asking ourselves for what values of x does 3 equal 3, the answer is all values of x because that equation is always true. Now, going back to the additive property of equality, most of the time we'll see this start as something like 5x plus 3 equals 5x plus 3. And those two equations are equivalent. So if we were solving and we ended up with 5x plus 3 equals 5x plus 3, we'd continue and we'd get down to something like 3 equals 3, which we know to be true and to be an identity. So it's true for all values of x. The other possibility we have is that we could get an inconsistent equation as a result. And in inconsistent equations are equations that are never true. And so equations that are never true. Now, what that means is that there's no value of the variable that makes that statement true. So no real number is a solution to that equation. So no real number is a solution. A quick example would be something like the equation 1 equals 3. That statement is never true. It's a false statement. And if we look at for what values of x does 1 equal 3, the answer is no values of x. So there would be no solution to that equation. Now, this is what we'll generally get as a result. Looking at the additive property of equality, we could take something like 5x plus 1, which would be an equivalent equation, equal to 5x plus 3. So 5x plus 1 equals 5x plus 3 is equivalent to the equation 1 equals 3. And that is then a false statement. There are no values of x that make that true. The last thing we'll want to note is that the solution set for an identity is all real numbers. We said all real numbers are solutions up above here. If we write that solution set, I'll just summarize how we write that. It's the set of all real numbers which we write as a curly bracket x such that x is a real number. And then with an inconsistent equation, our solution set, this one's an interesting one. So we said that no real number is a solution. So that solution set is the empty set, and that's written as a circle with a / through it.